All right, so today we're going to be talking about finding rational zeros. So far, they've been giving you one of the zeros, and you were finding the other two. Now we're going to find a way where we can find them all for ourselves without being given one to begin with. So to do that, we're going to use the rational zero theorem, also known as the rational root theorem, because zeros and roots are the same thing, right? So what this theorem says, it looks more complicated than it really is, but if I have a polynomial, and they give me just a generic polynomial that has integer coefficients, then every rational zero of that function has the following form. It's p over q, or a factor from the constant term over a factor from the leading coefficient. So all I'm really concerned about are the beginning and the end of the polynomial to figure out the possible roots or possible zeros. So if we look at example 1, I've got f of x is equal to x cubed plus 2x squared minus 11x plus 12. So what I'm concerned about is my constant, which is 12, and my leading coefficient, which I assume is a 1. So since the factors of the constant term go on top, I'm going to list the factors of the constant first. So 12 is my constant. So the factors would be 1 times 12, 2 times 6, 3 times 4. Those are all my factors for 12, right? 1, 2, 3, 4, 6, and 12. And then on the bottom, I have the factors of the leading coefficient. My leading coefficient is 1, so what factors are there of 1? Just 1. Okay. Now, and all of these are positive or negative because, of course, 12 could also be negative 3 times negative 4, or negative 2 times negative 6, etc. So for all of these, we're going to be talking about positive or negative. So I start listing my factors for my constant term. So I've got 1, I've got 2, I've got 3, I've got 4, I've got 6, and I've got 12. Okay, those are the factors of the constant. Then the factors of the leading coefficient are just 1. So is that really going to change anything to just put them all over 1? No. And then, of course, it would be plus or minus. So I've shown that to you that way, but I would normally just write down the answer right away from it. You don't need to write it over 1. Oops, I put my plus or minus and my comma in the wrong place. So your answer would just be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are all the possible zeros for that function. But not all of them are going to work. Right now we're just talking about possible zeros. Okay, so let me do one where my leading coefficient is not 1, just so you can see what happens there. So now I'm concerned about the 10 and the 4. So the factors, which factors are going to go on top? The factors of the 10 or the factors of the 4? Which one did I say goes on top? The constant or the leading coefficient? The constant, okay. So you want to remember that. This is the one that's going to be on the top of the fraction. This is going to be the one that's on the bottom of the fraction. So I usually write the factors of the constant first so that I don't accidentally write my fractions upside down, okay? So 10, my factors are, it could be 1 times 10, it could be 2 times 5, and that's it for factors of 10, 1, 2, 5, and 10. And then for my factors of 4, it could be either 1 times 4, or it could be 2 times 2. And so the actual, if I was just listing the factors, I don't need to list 2 twice. So 1, 2, and 4 are the factors of 4, and then 1, 2, 5, and 10 are the factors of 10. So I'm going to take the factors of 10, so 1, 2, 5, and 10, and I'm going to put it over each of the factors of 4. So it would be 1 over 1, 2 over 1, 5 over 1, 10 over 1. And then I'm going to take 1, 2, 5, and 10. I'm going to put it over 2. And then I would do the same thing, putting them all over 4. 1 over 4, 2 over 4, 5 over 4, 10 over 4. And all of them would be plus or minus. But before I do that, I'm going to take out my duplicates. So when I reduce the fractions, like my first row just becomes plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. If I go to the next row, have I written 1/2 yet? I haven't, right? So plus or minus 1/2. Okay, whoops, did not mean to cross that out. All right, now what about 2 over 2? What's that reduced to? 1, but I've already written 1, haven't I? So that's a duplicate. I don't need to write it again. What about 5 over 2? Have I written that yet? Nope, so that gets added to my list. Okay, how about 10 over 2? What's that reduced to? 5. Have I already written 5? I have, so I don't need to write it again. All right, 1 over 4, that's not a duplicate, so I'll write that down. What about 2 over 4? What's that reduced to? 1/2. I already wrote that down. It's a duplicate. 5 over 4 is not a duplicate, though, so I write that down. And then what about 10 over 4? What's that going to reduce to? 5 over 2. I already wrote it down. Okay? So you just go through and take everything from the first list and put it over everything in the second list and just eliminate your duplicates. Okay? Did everybody follow what I did okay? No questions? Okay. All right. These are just possible zeros, right? Like in the case of this one, it's to the 4th power. So the most zeros I could have is 4. Because the degree is going to equal the maximum number of roots. So only 4 of those are going to work. I don't know which 4 yet, and we're going to do that on the next page to start figuring out which ones work. But all right, so for right now, what I'd like you to do is for this function down at the bottom here, f of x equals 2x cubed plus 3x squared minus 11x minus 6. I just want a list of possible zeros for that one. Which factors are going to be on top? Factors of 2 or 6? Which ones are going to be on top? 6, yeah. So you might want to write those first, if you haven't. Okay, so you should have gotten plus or minus 1, plus or minus 2, plus or minus 3, and not 4. That should be 6. My bad. Plus or minus 6. Ah, wrong pen. Plus or minus 1/2, and plus or minus 3/2. Questions about where those numbers came from? Nope. Okay. All right, so now that we have a way to find possible zeros, we can go through and figure out which ones actually are the zeros. So the rational root theorem gives possible roots, or zeros. Okay, but that's only possible ones. They don't all work. So what we have to do is we're going to use synthetic division to see which ones are actual roots. Which are actual zeros or roots, either way. Same thing. Okay, so if it's a root or a zero, what's my remainder going to have to be? The remainder has to be 0. So if I plug it in and do synthetic division and I get a remainder of 0, then I know that I've found one of the roots. So for example 2, we're going to find all of the real zeros for f of x equals x cubed minus 8x squared plus 11x plus 20. So first I have to think about what are my possible roots. Four zeros. So since this one has a leading coefficient of 1, then I really just need to worry about the factors of 20, since I'm just going to be putting them all over 1. So it could be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Now, do you think I'm going to have to test all 12 of those numbers? No, I'm not going to have to test all 12 of them. Because as soon as I find one of them, I can do the synthetic division and get an answer that's a quadratic expression. And once I have a quadratic, I can factor it or use the quadratic formula. Okay? So let's go ahead and do this. So typically I would start with the small numbers, the easy numbers. What's the easiest number? 1, right? So let's try 1 and see what happens. So my coefficients are 1, negative 8, 11, and 20. So if I bring down the 1, 1 times 1 is 1. Add those together, I get negative 7. 1 times negative 7 is negative 7. Add those together, I get 4. 1 times 4 is 4. I end up with 24. So I have a remainder. That means 1 is not a 0. So now I'll try negative 1. So 1, negative 8, 11, and 20. So I bring down the 1. 1 times negative 1 is negative 1. Add those together, I get negative 9. Negative 1 times negative 9 is positive 9. Add those together, I get 20. Multiply by negative 1, I get negative 20. And now my remainder is 0. So I found one of my roots. One of my roots is negative 1. And I can take the answer to the synthetic division. That's going to be x squared minus 9x plus 20. And I can factor that. So if I factor x squared minus 9x plus 20, what's it going to factor into? X minus 5 times x minus 4. You guys all agree? Yeah. So that means that x is going to equal 5 for that one. X is going to equal 4 for that one. So all of the real zeros would be negative 1, 4, and 5. So you might have to test 2 or 3 before you find a 0, but usually 1 turns up. And then once you have a 0, if it's a cubic polynomial, you can just use the quadratic formula. Okay?
We ever have to test all of them?
You should not ever have to test all of them. Because I didn't have to test 4 and 5 to find them, did I? So I guess potentially you could have to test up to 10 of them and you'd find the last 2, but I don't think it's going to happen that way. Like I said, most of these you find it within a couple trials. Okay? Question? How do I know to stop once I have 3 zeros? Well, there's nothing else left to do. There's nothing else left to factor at that point. But also, like I had said before, it's because the power is 3. I can't have more than 3 zeros. That's the most I'll have. I might have 2, I might have 1, but I can't have more than 3. Okay? Alright, so I'm going to give you guys one to give it a shot here. We've got f of x cubed minus 4x squared minus 15x plus 18. I'll let you guys try and find the zeros for that one. Okay, so on this one, if you tried just positive 1 to begin with, it would have worked. And then you're left with x squared minus 3x minus 18. That factors to x minus 6 times x plus 3. And so your zeros end up being negative 3, 1, and 6. There might be a problem where you have an x to the 4th And unfortunately, there aren't very many examples of that in the book. But if it turns out that your original polynomial is to the 4th power, then you're just going to have to do synthetic division 2 times to get it down to where it's a quadratic. But I think you only have one of those on your homework tonight, and maybe 2 tomorrow night. So that shouldn't be too bad. So, any questions on this? No? No questions? Alrighty. That's all I got for you guys today.